Lions, who will talk about JBoss GPPM.
Thank you. Can everybody hear me in the back? Okay. Thanks to FOSDEM for the invitation. And today I'll be talking about JPDL, which is a process language for workflow, part of the JBoss JBPM product. So JBPM itself covers many process languages, and JPDL is one, and that's the one we'll focus on. But first, a little bit of introduction. You might have heard, actually it's a question, who heard of workflow, business process management, and or orchestration before? A couple of them. Who's pretty skeptical about these technologies? A few honest guys, that's good. No, because typically, and this is a typical developer audience, and with developers, workflow and orchestration and BPM, they tend to be quite skeptical. Whereas managers, they see some graphical picture, software comes out of there, this is great, we can get rid of all our difficult developers. So they like it very much instantly, whereas for developers it usually takes a lot more to convince them about this technology, and that's what I'm going to try to do here today. If you've seen these pictures about these heavyweight engines, these monolithic engines that do BPM and workflow, you might have seen different solutions, and they don't look very much like each other. There is a lot of difference, a lot of fragmentation in that market. What I'm going to try and show you today, that whichever version of BPM or workflow you take, it all boils down in the end to state machines. So the unification of all this is a simple state machine, and there is a number of features that we build on top of that. So first of all, what is a process language? We'll start from a business process. A business process is a description of how people and systems work together, typically done in terms of activities. They express the flow between the activities. Typical examples are insurance claims, expense notes, that kind of things that are modeled as workflows. But very important, and that's where we differ a little bit from the vision of competing products. We see that there are two different targets for BPM and workflow. On the one hand, we want to model things. We want to describe and analyze the problem domain. For instance, recently I was at a laboratory where they modeled how these samples were processed. And they had a whole description of how these plates with 96 samples could be split, merged, and how they were treated. But while they were describing that process, they were not even thinking about what kind of computer system do we want in the back, what kind of interface do we want, which steps do we want to see automated. So they were not thinking about a software implementation, they were just describing a problem domain. So that's where modeling is different from implementing a software system. And that's the second target. Second target of workflow and BPM is executability, which means we want to have the same process that we used for modeling. We want to use it as a basis for our software implementation, for specifying the behavior of the computer system. And that's where there is a trade-off between these two, because if you have an analysis tool that allows you to draw your process very freely, like Visio, or maybe you've heard of ARIS, the IDS shear tool, you can model your business processes, but you cannot execute them properly in that environment. You can draw them, and in the description, in the drawing, you are completely free. So that's one kind of technology. The other end of the spectrum is a general purpose language like Java, in which you are free to make everything executable, but you cannot have the graphical picture. And that's where JPDL tries to make the bridge between the two. So there is a trade-off. The more you want the process language to be executable, the more technical details you have to enter, like transaction management, concurrency support, and what have you, in which your business analyst is not interested. On the other hand, when a business analyst draws a picture, it might not be executable. So there is a trade-off, but there is a common intersection, let's say. And that's what we want to That's what we are actually offering in JPL process language, which is if you put some restrictions on how you model, then you can make your processes executable. But definitely the important thing is that we see a trade-off between these two worlds, and you cannot have free modeling and executable at the same time. And the typical approach, and this is very, very important, I'm going to focus here on what can we make graphical and executable. That's what I want to try to show you today. But also be informed that a typical BPM approach, when you see something graphical, that's a different approach. That's just creating something graphically and trying to make it executable. But then you have to be aware that not always the business analyst will understand these pictures. A typical example is BPL. BPL is considered a BPM language, at least not in my opinion. It is a very good service orchestration language. BPL actually allows you to script a new web service as a function of other web services. And this is something which doesn't really relate to the work that the business analyst is doing. And yet it's promoted for that kind of solution. So then, what is a process language? Here you can see a real example or an indication to what JPL is all about. On the right, you see the XML syntax, in XML syntax embedded process language that describes the activities in your process in an XML format. On the left, you see the process graphical picture, just a graph-based picture. Now, you should really consider this as two independent, or let's say, no, these are both representations of the same process. So, one is a diagram, and it just shows you the structure. It doesn't show all the details. While in the XML, you will find the structure plus more details. And from the XML, you can generate a picture. So why would you use a process language like JBoss? First of all, to simplify your implementation of long-running processes. A lot of you will be hardcore developers, so you know that an imperative programming language like Java or C is very good at expressing a sequence of instructions. But while you're executing that sequence of instructions, you cannot have a wait state, at least. So if you have an insurance claim, for instance, that might be multiple requests to the server. So the first time request comes in, you start to doing processing. You start to execute a sequence of instructions. Now you need to wait until some other person invokes a new request. You cannot just block the thread until that thing happens, because if you reboot your server, your thread is gone. So you cannot persist your call stack. That's basically what it comes down to. Traditional programming languages are not good at expressing long-running executions, and they are not able to cope with wait states. So that's what you can get by using this process language approach, because basically what you can do is the graphical process, the graph, you can just store it in the database. And then you have an execution pointer that keeps track of where you are in the graph. Now, both of those can be saved in the database. So later on, you can retrieve where you were in the execution of the database and continue from there on. So that's that kind of state management can now, with a technology like JBoss, be extracted from the rest of your software, so that you can focus on other things and just as a separate aspect model the wait states and the persistence. So a second reason why you would do that is to keep the overview and improve communications. So if you have to talk to your less technical people, if you as a developer need to talk to less technical people or to other developers, it might be handy in a meeting to have a picture and so that you can physically pinpoint, this is the step I'm talking about. This is the transition. When this happens, an email should be sent. Whatever. So it's a nice instrument to improve the communication. Now, in general, when would you use a process language? for any aspect in software development where you want a diagram, a graphical representation of the process, which represents some form of execution flow, and which must be able to handle wait states. If those three conditions are met, I'm pretty sure that JPDL will be a good solution to your problem. And this can be very low level. It might be that you have a Java class that you think as a developer, oh, I see some kind of wait state in here, let's try and model this graphically. You can use JPDL for that. On the other hand, if you want to talk to your business analyst about how your organization works and how the business processes in your organization works, that meets these same criteria, so you can also use JPDL on that level. So various levels, but these three aspects need to be, if you have those three conditions, then the JPDL process language is a good fit. On the other hand, you also have history and statistics for feed. When you model it as a JPDL process and you execute it afterwards, there is automatic logging in there that keeps track of this time, this activity was entered, the user was presented with a task, and later on you can see this user has entered these data items and submitted it so that the process moved on. So there is auditability and traceability of the execution that you get from the engine. Now let's look at JBoss JBPM. It's kind of product, or actually it's a framework, or let's say a set of building blocks in plain Java, in which we implement various process languages. One of them is JPDL that we covered today. And basically the process virtual machine is one Java library that allows you to specify process graphs and execute them on a generic level. But we have built this process virtual machine in such a way that we know that all the features that we find in process languages and workflow languages can be built on top of that. And each process language has got its own environment, its own type of process nodes, and its own features and functions that it wants to implement. So for instance, JPDL is a language which targets a clean integration with Java, and it also has a focus on task management, maintaining tasks for people, creating tasks, and allowing users to submit results for their tasks. So that's a number of features that we add on top of this state machine technology, which is in the process virtual machine. The same for Beeple is another process language in a completely different environment. Now we're in a web services environment, typically an enterprise service bus. And the Beeple process language allows you to script the web service as a function of other services. So it's another environment where you want, let's say, process variables as XML snippets. Whereas in JPDL, you want Java objects as process variables. And then there's also a page flow language, which is part of JBoss C, in which you specify your pages as nodes, and the transitions are the navigation between the pages in your web application. So we already have been able, for these three languages, to build them on the same core technology, the process virtual machine. And we're now starting work on XPDL, which is another standard in the area for business process management, and building it on top of the same. This is pretty unique because in the Java landscape, you have no other BPM or workflow engine that is able to support more than one language. And what you see in the market is that there is no convergence between all these different languages. Instead, they diverge. You see more differences between the process languages each week lesson or each month. So there is no convergence towards a single language, and we are the first ones to adopt a multi-process language strategy. Actually, there's only one other system or one other technology that has a similar kind of approach with multiple languages, but you probably don't want to hear about it because it's Microsoft's workflow foundation. So this is your only option. So here you can see the scope of JBoss JBPM. It's the process virtual machine implementation plus a set of process languages on top. Now, if you as a developer have the use case for workflow or BPM, you have a certain environment. Either you want to do it in a Java environment or in a web services environment. So you know what kind of language you're looking for, so you will be looking for the specific JPDL or debugged process language solutions built on or as part of JBPM. But now you know that they are actually built on top of the same core technology, which is especially good if you consider the future, meaning that whenever workflow and BPM technology becomes ubiquitous mindshare amongst the developers, and you will be using it a lot in different situations, are you going to use multiple engines in your development, one for each language? So the nice thing about JBPM is that you can combine those and use just one engine for the different languages. So now let's take it from a different perspective and look at a first example. And especially I want to concentrate on developers' audience, in which I want to give them an indication of when to use plain Java development and when to use process technology. So we're going to start with a very simple process. We're going to model how a door works. Should be pretty straightforward. And we're going to do this first in a Java implementation, so that you know what we're talking about, and then we're going to see the JPDL process implementation. So there are 4 door states. The door can either be locked, closed, open, or open and locked, in which case you cannot close it directly, so first have to unlock it, close it. So and then you have a number of transitions between those. So there are 4 different operations. You can unlock, close, and open this door. Now let's look at the Java implementation. So you could model it as a class in which there is one member field which represents the state, called the state member field. And it's always one of the 4 constants that you see defined on top. So those are the 4 constants. And the member state, the state member field, it has one of the 4 variables, or one of the 4 constants. And now we're going to look at the method lock. So you have 4 methods, or 4 operations in this door behavior. One of them is to lock. So all the other 3 methods, unlock, close, and open, are pretty similar from this method, so we're only going to cover this one. But it shows already very clearly on top that you have first a part in the method where you're going to check in which state am I now, and am I really able to call this method? Because you see, this is a state machine, and you only can provide a number of signals, or a specific number of signals in that given state. When we modeled it as a Java class, we had to define the 4 methods as public. And these methods are always available. You can always call them, so you need to check whether this is actually allowed to call that method in the given state. So if the door is already locked, or if it's open and locked, then you can't lock it any further. So you check that and you throw an exception if there's a problem. Then the second part of the method is to update the state variable, because if you lock it, depending on your previous state, if it was closed, then you assign the locked state to the member field, and if it was open, you assign the open locked state. And that's the implementation of one of the 4 methods. So now we're going to look at how this same behavior is implemented with a JPDL process. Note that now we don't see one of 4. So previously I had shown 2 slides, and already, and not all of it, so 3 methods were left out. Here you see the complete implementation of the door process in 1 slide. So you can see the different states and the different transitions. So this should already give a clear indication as to what kind of problems benefit very much from this workflow technology, from the process language. So for this problem, it means that it's easier to express it as a state machine versus separate methods. And it doesn't, by making the comparison between the Java and the JPL, I mainly want to give you an indication of when it's better to use JPL. I don't want to give the impression, like typical BPM and workflow products, that everything is a process, everything should be centered around the business process. That's an impression that you get very quickly from BPM products, and especially what they try to do, or it's mainly a consequence of the fact that they're monolithic systems, and they're built to run processes and business processes and workflows. But what if you want to do some Java behavior, or what if you want to program? What if part of the solution is the process and part you just want to write Java code? That's where they don't mix very well in a typical engine, and that's what I'm going to try and show you here, that with this process language, JPL, it's very easy to mix and match processes with Java coding. So we saw already the complete specification of the state machine. So now we're going to do something extra. We're going to walk you through a JUnit test in which we're going to verify if the process that we just created actually implements the right behavior. And in one go, you can get an impression of the APIs that you can use to invoke these processes. So first you see a static member field, which is process definition. So this corresponds to the process that you just saw, to the XML and diagram image. So you see one member variable there. There's one for all of the tests in that test suite that we're going to test case. The XML file that you saw describing the process, it was in the file process definition.xml. So we load it as a resource, and we parse it, and we get a process definition object. This represents the whole process, and now we're going to see a test method in which we can execute this process. So the process definition is always static, and then we have, per execution, a kind of data structure that keeps track of where you are in the process. But you always remain one process description, let's say, and multiple executions. It's the same relation as between Java classes and instances, object instances. So let's look at this test method. In this test method, we're going to create a new process instance for the door process. This actually creates one instance of the state machine, and you start off, that was indicated in the process, you start in the locked state. So then, the actual pointer to where you are in the process, that is indicated by the token. The token is the pointer to where you are in the process, and in order to support concurrent paths of execution, the data structure is a tree of tokens. So one process instance corresponds to a tree of tokens. Of course, for a door, we just have one path of execution, one token, the root token. So that's what we fetch here. Okay, so now what we're going to do is we're going to send a signal. So this is where you can see graphically the token. This is your runtime data structure. This is your fixed process. Okay. So when the process instance is created, in the yellow marked part, after this constructor, the root token is positioned in the start state, which in this case was the closed state. So now we're going to invoke the signal method, which means this is an external trigger so that the state machine will take a transition. In this case, we're going to look for the lock transition and take it, and then inside of the signal method, we are going to do the calculations until you end up in a new wait state. So you might potentially have a number of automatic steps in between, but eventually you will end up in a wait state. So if you take the lock transition, which is here, you can see that you will end up in the lock, which is another wait state. So that's where the calculation stops, and the pointer will be updated, the token pointer will be updated towards the lock. So now you can see that you can persist both the process and your runtime. So of course, during in a persistent environment, so if you want to do real BPM or workflow with it, typically you deploy your processes to the database and they're already there. And then at runtime you start a number of processes and provide the external triggers in one transaction. So the process is already there and you only insert the token records with the pointers towards the states. So then, again, we're gonna, one other important aspect is that this is a unit test, which means that for each test in a unit test, it means we're gonna create one instance and run it through one scenario of the process, feeding it all kinds of external triggers. Typically, these might be with a long time in between, because in between the signals, you might store the process execution in a real life situation. But here in the unit test, we're going to feed the external triggers and then check if it ended up in the wait state we expect. So also this is pretty important and a big differentiator between typical workflow solutions and what we do in JPDL, because we don't have a heavyweight deployment structure. You can just write your scenarios in a simple unit test and check their behavior just as you do with normal Java coding. So next, the unlock method. Here you can see the unlock method. So if you feed that external trigger, the token will be updated and it will point again to the closed state. So now suppose that in this scenario we want to call the unlock method again, and of course you see that from the closed state there is no transition that is called unlock. So you cannot unlock an open door. So then you get an exception from the end. Okay. So now you saw already some basic wait states. So the capability of handling long-running execution and wait states, because the door process has 4 states. That's an important aspect of workflow and BPM. Now we're going to look at the second key feature of the JPDL language, which is tasks. So we're going to look at how a task looks like to specify and how the tooling, also give you a little bit of an impression on the tooling around this process language. This is just a screenshot of the designer, and this looks very similar as the tools that you see around BPM technologies of competing products. Only this is a little bit different in philosophy. The philosophy is that we target a designer both at the business analyst level, but also at the developer's level. So here you can see we're in the diagram tab, and that's where this is a graphical editor. So you can select this task node, in which case you can have a form to enter all your data, and this will translate into XML underneath. And that's what you can see in the source tab, as I will show you now. So if you click on the source tab, you will have the XML, similar as we saw before, that describes the process, but now this is an editor towards developers with code completion and syntax coloring. So you don't need to click your way through the process. If it's faster for a developer to type in the XML, you can just do that. And the nice thing is that both of these editors, they operate on the same runtime model. So there's no round-trip engineering. There's no markers or whatever. They operate on the same runtime model that's internal in the IDE. And you get one file that's saved, which is a process file. So no round-trip engineering, direct synchronization inside of the editor. So if you change something in the text format, in the XML, you immediately see it changing in the properties trigger and the other things. So that's the different spirit of this tooling versus the other toolings. So now let's look at we were working our way towards the task in JPDL. I'm just going to give you, let's say, some highlights of the features that we offer in terms of task management. There's various ways on how to assign tasks to people. One of the ways is swim lanes. You see here, this is the swim lane. This task is assigned to the swim lane manager, and that means that manager is a kind of process road. For this process, there will be a manager involved. And there might be multiple tasks for this manager person. So after the first time, when you selected one manager for this particular process, that will be remembered. And if later on there is another task for the manager, he automatically gets it in his inbox. He or she. Then there is a notification, which means some email integration based on templates, so that you have an automatic email notification like there is a task in your inbox. Here's the link to it. There is some priority, of course. And with the swim lane manager, there are other ways of assigning it as well. So you can have direct assignment to people or to groups, which is also quite common. Or you can just revert. You can specify a Java class in there, and then you revert to plain Java code in which you calculate the users you want to assign it to. So you have all the options. Another feature in tasks is a reminder email. So you just specify after 2 business days, start sending a reminder email for this task every 4 business hours until he did it, until the task is closed. Of course, this only has to be done in case the task is not finished. Then there is other kinds of timers that you can specify. For instance, you can say in the process, after 4 business days, if then the task is not completed yet, take this transition. Alternatively, in a timer, you can also specify some Java class and say execute this code after 4 days. So in this case, we're going to take the escalate transition after 4 days. And then there is a number of transitions going out of this task mode. So this gives you a good indication of what kind of features are in there and when it will be easier for you to specify this kind of XML versus coding all of that yourself. Once you've done that, with the graphical designer, you can generate some forms for each task, and then this corresponds, the upper block corresponds to the task form in which users, One thing you don't see is the task list. So people can look at their task list or start new processes. Once they click on one task in their inbox, they can easily generate this kind of forms in which they can fill out their data, submit the task, and the process continues executing. So this is the kind of console and workflow participant web UI that we've built as part of the tooling around the JBoss language. So far for tasks. Now we're going to focus on integrating Java code with processes. So we saw already wait states and task nodes as workflow constructs in the process. But JPDL has a number of other constructs as well, like start states, decisions, forks, joins, process states, and so on. So it's got a complete list of process constructs that you can use to model your processes and to make them executable. But very important here are the last one, or is the last one, the 3 dots, which means that a big part of the vision is that you cannot specify a process language in 20 constructs or in 10 constructs and be complete and be generic enough so that you can tackle any kind of workflow problem with it. So we explicitly left open the end so that you can, for instance, if your business analyst says in this node in the process, I want to do something really strange, there might not be a corresponding process construct in the palette of the generic tooling. But what this open-ended means is that in JPL you can always revert to Java coding to do something really weird if you want to do that. So if your business analyst says, in this node, I want to first send an email, now wait for something, but if it doesn't happen, or I don't know, maybe it doesn't fit one of the constructs already there, you can just type in your code, reference the Java class in your tool. So that's basically the most important use case for binding Java code to processes. And that's what we're going to cover now. So there is an API for describing runtime behavior. And basically, on the one hand, you can do everything what you can do in Java. On the other hand, you can access the process variable, the process state, and everything related to your long-running processes. And also, if you're implementing a workflow construct, you can determine the propagation of execution. And this is also something, this is a really new concept if you're just used to sequence of instructions in normal programming language. This is something different. Propagation of execution means if you're implementing a node and you want to keep on taking that transition to the next node automatically without a wait state, you just invoke leave this node over this transition. You invoke a method for that. If you say, I want to behave as a wait state, I want the signal method to return, I want to persist the whole situation and only wait for a new external trigger, in that case you don't do anything. You don't invoke any method and the node will behave as a wait state. Or alternatively, you can start off multiple paths of executions that run concurrently. So that's propagation of execution, and that's where there's an API for. So now the node constructs of the process language now become a kind of components. And that's a very interesting aspect, where a process language is no longer just handed to you like these are the constructs that you can use and you have to model your process in these constructs. No, it's different. Like we have already a pre-built set of process construct components, the node types, that are implemented, and if you want to do something else, you can revert to plain programming to extend that set of components. But if you say in our environment, we're working in an insurance environment, and validating in insurance is something that happens a lot. So let's build a new process construct, validate insurance claim. And you can write some reusable code in there, and so process construct becomes a component. So the quest for UPL is over means that previously the BPM, typical BPM and workflow products, they tried to build the best process language ever in which you could do anything. And I believe that's now done with, or let's say, we believe much more in a vision where you have each process language being a set of constructs, and even that is open-ended. So there's no, if you hear a BPM company saying we've got the best process language ever, it means that they only have one language. That's how you can interpret that. So let's zoom in a little bit deeper on how we can bind process to code. First of all, an indication to the use cases. When do you want to bind process to code? That is, for instance, in the node behavior, if you want to implement node behavior. Secondly, if it's not attached, so you have the process graph structure. Now, not in the node, but somewhere invisibly. For instance, on taking this transition, I want to execute a piece of code. Or when you leave this node, that's not really related to the graphical structure. You just add a kind of listener, like when the execution goes over this transition, execute this piece of code. Also for task assignment, decisions and timers, those are good examples of use cases for binding Java to your process. Okay, you might want to build reusable pieces of code that, for instance, sending an email is a very good example that you might want to do in several locations in the process, but of course in each different location you have different parameters different configuration parameters that you want to give. So there is a configuration mechanism for this code. So let's quickly go through it. So the example here is an action. We want to listen to the execution taking a transition, and in that case we want to calculate a number. So there is in JPPL an interface action handler in which you can implement concrete clauses. And the execute method will be called by the engine when the transition is taken. And the execution context gives you access to all the process state and process variable information. So here is one implementation in which you calculate some number. You start off by getting a process variable. You do some calculations and you set another variable. So you do a variable update. But now, of course, we want to reuse that calculation in various places in the process with different configuration parameters, and that's where you can just use plain member fields. So now, when you use this, those were the things that I talked about, right? So now when you're building your process, then you specify a transition. You can reference the Java clause, and optionally you can inject values into the member fields, just by specifying them like this, so that you can reuse the same implementation in different situations. There's also an expression language which is pretty interesting. It does exactly the same as you saw before, only there's a different way of specifying what code has to be called. Now there's a number of named objects that you can reference in a process. Of course, the variables are the most visible ones. So if your process has a set of variables, those are Java objects. So with an expression like this, you take the variable pay raise, whatever object it is, and you calculate number method on there. So it's just another way, a very interesting way of referencing Java code from inside a process. And this is based on the standard Java expression language. So one nice thing that could be built on top of that is the decisions. In decisions, you can specify a condition on every transition in this plain expression language. So you will evaluate the conditions and take the first transition for which the condition is true. Okay. So let's quick roundup of the JPDL features. So I think it has a superior and modeling and execution environment in which we are able. So I just quickly list off this, basically you can read it afterwards. But there's no other language in itself that covers these kinds of constructs. So basically this is on the level of the process virtual machine where you can handle any kind of construct, or not only construct, but any kind of pattern that you'll find in the process languages, like wait states, like concurrent paths of executions, like binding it to Java, hidden actions. Those are all things that you might find in the process language, and basically this list that JPDL supports is the union of what you'll find anywhere else. So this is what you also can see by the fact that we support multiple languages. The core engine has to support them all the features. That's what the key differentiator for JPDL, and JBPM is versus other workflow engines. So typical JPDL process language features are task management, you get automatic audit trailing. Process variables are in JPDL process variables, and you have pluggable node behavior, which means you can write your own process constructs. Also very interesting is JBPM is just a plain Java library and it's embedded. So you can use it in your own application. It's not a separate monolithic engine. You just include some Java libraries, you create your tables in your database, and JBPM can work with that. So it's embedded. And we see that sometimes, let's say half of the use cases for JBPM is when it's used as a standalone product, half of the other times it's used as an embedded engine. And both these JPDL and JBPM in general works on an enterprise Java platform, but also on a standard Java platform. So you don't need to have an application server. You can run it in Tomcat or in your Swing application. and it also plugs into various databases. Because of the Hibernate gPC abstraction, we can run on Oracle or any other database that you have in your project. And the pluggable services I already explained that we run on both enterprise and standard environment. There's no real time, let's say, unless we come back to it in the questions, to compare it to Beeple. But basically, as I already told you, JPL is Java, Beeple is web services, and they both do long-running executions. So it's the environment that is mostly different between the two process languages. So the conclusion, if you only remember one thing, is that JPL is a good match with Java, and it extracts state management from your software. And it supports long-running processes, which means wait states. It's embeddable, and it's JBoss JPM in general is a platform for building process languages. We have 3 already implemented, and there's more to come. I think that sums it up, so we can open the floor for questions. So the question is, there's no standardization for it. Yes. Okay. Well, let me first answer the first, because otherwise I forget it. So the question was around standardization for workflow, BPM, and all that. So what's the vision of that? So basically, there are a number of standards. Basically, there are many standards, and they're not really converging. So they're also a bit diverse, and it's a bit of a fragmented landscape in the standardization place as well. So currently, there is Beeple as well recognized in the BPM area, which is in fact the web services specification. That's one thing. Okay. So there are a number of standardization efforts in place. XPDL with Workflow Management Coalition is another one, and they have been working on this for a longer time. So those are 2 process languages. They specify the XML in which you express the process, right? So those are existing standardizations. Where I think a standardization effort is missing, and where there's no standard, is in the binding, in the Java API, to implement components for a workflow engine. So, as I told you before, like the separation between the process virtual machine and components on top. What API can I use to implement a workflow construct? If there would be a standardization effort around that, I think it would be a great advantage, because that would leverage the binding between Java and process languages. And that's something where there's nothing now. Now you choose for Java or a process language, and there's a big gap between them. So that's where I think it's missing. Coming back to BPMN, which you also referenced. So BPMN is a process language standard which doesn't focus directly onto the XML of describing the process, but it focuses more on the graphical representation of the process. And it is, in that respect, a little bit different. What I think will happen is that BPMN is getting a lot of traction. So nowadays, BPEL is known very well. XPDL is not known that very well. And what I expect is going to be happening is that currently tool vendors are implementing BPMN support, so the graphical representation support for BPMN on top of Beeple engines. This is not a very good match. If you have worked with the combination before, you'll see that there's a lot of constructs in BPMN that don't match very well into Beeple and the other way around. But tool vendors are adopting it anyway, so you'll get more focus on BPMN in the short future. And what you'll then see is that when you're using BPMN, it matches much better to XPDL. So that's what I think will happen. So the focus will shift first to BPMN, the graphical notation, and then people will realize that this maps much nicer to the XPDL standard, and that's what I think will happen over time. Does that answer your first question? Yes. So the question is, you saw the graphical designer, and I talked about the pluggability of node constructs, and there's not yet an infrastructure in place in current versions in which, let's say, that pluggability also covers the designer. What you can do is you can model plain nodes and reference your Java class in there. That's what's already supported. But if you want a special kind of XML or a special icon or a special form for your specific configurations, that's what you can't yet plug into the designer. It's definitely something that we envision for the coming future. But for now, it is only possible to reference your Java class from the current JPDL. You can already reference your Java class and configure it. And this is, let's say, supported in a generic way, but not yet in a way that you can associate forms or a new icon with it. That's basically. Other questions? Yes? So, what was the last part in the database again? Okay, so the question is, how are these processes stored in the database, and is it tweakable? First of all, what we have is the core essence is a Java library, so you work with Java objects that describe the process. And the persistence is decoupled from these Java objects. So you can always just have your own persistence layer that takes the Java objects and map it, right? So that's the basic level. Then the second thing, what we have on a persistent service is to use Hibernate. So Hibernate can map Java objects very well to the database, so you can start tweaking the default Hibernate mappings that you get out of there. So where you might, let's say, leave out a column, or change a column, or tweak the default schema that comes out of there. So that's another level of tweaking. Does that answer the question? Last question, and otherwise you could come down or we talk further outside. Okay. Yes, versioning is again. So the question is, what happens with versioning if you have new versions of the process? This is pretty different from traditional software, because if you have an application server and you have enterprise beans deployed on there, it's always one version of the enterprise bean that's deployed, because you can always assume that when requests come in, they are handled pretty quickly, and you can, with a redeployment, just wait until all the requests are done and then direct new requests, so you only have to have one. While in processes, that's not the case. You might have a long-running process like a legal case that takes 2 years, right? And then you might have a new version of the process that's different. And so the default mechanism that comes out of the box for versioning is that whenever you start a new process, you start it in the latest version, and it keeps on executing in the same version. When you deploy a new version, the new executions are started in the new version, and the old executions, they keep on running in the old version. So that's the default behavior, which can change, of course, but that's what you get out of the box. So, and of course, you don't want to, let's say, enforce the fact that there is process migration, because that might be tricky. In the old process, you might point to a node that doesn't exist in the new process, for instance, so that's more tricky. So the separated versioning is what you get out of the box, and this also goes to the level of the classes. So if you associate classes with your process, you can version those classes as well. You don't have to, but you can. In which case, JBoss keeps track of which process is executed and it takes the right version of the right class. So, thank you very much.